Well, hey again, Mr. B here. A really important topic moving forward is homeostasis, and it comes from two sort of interesting Latin words. The first is homeo, or homo, which means same, and stasis, meaning balance. Our body systems need to be in balance and need to be working with each other to keep us healthy. So, what do I mean? Well, let me show you. Now, figuring out all the goings on in the body is largely the function of our brain. And just I'll zoom in here for a second. There's a little region kind of in our midbrain, right around here, called hypothalamus. And it's got lots of blood vessels, and it does lots of sensing, everything from temperature to carbon dioxide to hormonal levels. So it's involved from everything keeping you warm to helping you deliver children. So a few examples we have here. If you're too warm, your hypothalamus can basically tell your skin to secrete sweat, cool you down. Other organs that are involved in homeostasis would be your kidneys, they keep your salt balance, they keep your water balance. Your pancreas, which you might have thought was just a digestive organ, also helps to maintain your blood sugar levels, your glucose levels. Your blood is even in on the act, helping to distribute heat. And if you get quite cold, your blood vessels will dilate a little bit to keep heat in your core. So these are all tricks of maintaining the balance. Even your muscles down here, think of a shiver reflex, for example, are involved in heating you back up if you get too cold. These are just a few of the body systems that are involved in maintaining that constant internal environment that we have to have called homeostasis. One of the most famous ones is temperature control. Now, it's analogous to the way things function in your house. If it's too hot, you can turn on the air conditioning. If it's too cold, there is the heater. So we have these mechanisms, and it's interesting when you look at how it works, because our bodies often react using a negative feedback loop. So what do I mean by that? Well, if you're too hot, your body will do the opposite, and it will bring your temperature down. So if you're too hot, your body tries to bring your temperature down or make you colder. If you're too cold, your body will try to act in the opposite direction to warm you up through shivering. Now, we call these negative feedback loops, and there's two types of reactions that your body can have. One is acting in the opposite direction to what's going on, and the other is, well, going in the same direction as what's going on. So they're negative and positive feedback loops. Here, you're looking at negative feedback, where you do the opposite thing to correct the imbalance. So in a negative feedback loop, there's a stimulus. Your brain senses that perhaps you're too cold. And that information makes a little bit more sense. That information will get back to your central nervous system, and then your central nervous system will send out an all call. And for example, you'll start shivering, and that will get back to your brain through the sensors, and your brain will notice that you've warmed up. Okay, so that's a negative feedback loop. The opposite thing is happening. Conversely, if your body temperature exceeded 37 degrees, you were caught in a desert or something, the nerve cells would pick it up, and your hypothalamus would be aware of it, and your sweat glands would be told to produce sweat to cool you down, or to perform the opposite of what's happening to you, to try to keep you comfortable, keep you alive, keep your body systems working. So here's a good example. We take a look at a little sort of animation here. So if you're too cold, right, you need to turn the heater on. And if you're too hot, you need to turn the heater off. So this is a feedback loop, but each time a correction is made, it's to create the opposite effect. So we call this a negative feedback loop. And it basically works like this. Your brain senses what's going on, and it sends a signal out to your glands. Now, that could be to produce a hormone, or it'll send a signal out to your muscles to create an effect. So your glands and your muscles are what we call your effectors. They're what create the change. So here's a neat animation. For example, if you get too warm, your blood vessels under the surface will dilate and you'll produce sweat. Okay, so that's your body reacting to things going on. Your hair also lies flat, right? Cooling you off further. Now it's a little bit different. This is interesting. Um, our hair will stand on end if we're cold. Now, that's to create sort of a layer of air. Now, in humans, we're just not hairy enough to trap any air here. But in things like dogs and cats and bears, wolves, etc., standing the hair on end will keep you a little bit warmer. And you pull the blood vessels, they sort of pull away a bit. They constrict to keep the blood away from the surface of the skin. Okay, this is all being done to keep heat further down in the core to not lose as much. So this is a negative feedback mechanism. Okay, so here's your feedback loop. This is a classic negative feedback loop that you'd want to know for any assessment. Body temperature rises, hypothalamus takes steps to lower the body temperature. Makes sense. If your body temperature lowers, let's say you were experiencing hypothermia, this is where your body temperature would rise because of shivering. In each case, pay attention to this arrow. This arrow, in this case, if you were too warm, brings you back down. In this case, if you were too cold, this brings you up. So your effectors start to compensate for what's happening to you, to either cool you down or warm you up. So that's the negative feedback. It acts in the opposite direction of what's happening to you. But there's also one called positive feedback. Now, in humans, for example, we can get fevers, and it's interesting. Our body will amplify our fever because it's trying to increase the temperature to allow white blood cells to get in and kill the germs. So we can get a fever that can rise and rise and rise, and it can become a bit of a problem around 102, 103 degrees. My kids reliably barf at about 101, right? And you can bring a fever down with acetaminophen. So that's an amplifying loop, and your body will break the cycle at some point. Here's a second example we'll look at here. When it's time to deliver the baby, it begins to press on the cervix right down here. When those cells stretch, I have to zoom out, it sends a signal. Okay, so the sensors are here, and it sends it back to the hypothalamus. And the hypothalamus tells the master gland right here, okay, now the pituitary has two lobes, anterior towards the front, and posterior facing towards the back of it, more towards the rear of the skull. Now, you might have heard of an oxytocin drip that they'll put women on to induce labor. What does it do? Oxytocin is a hormone that the posterior pituitary makes, and when that hits the blood and it gets back to the muscles of the uterus will contract even more. So as the baby pushes on the cervix, that stretching is a positive feedback loop because it sends more oxytocin. Now, the cycle's only broken when the baby is born and there's no more pressure on the cervix. And then that just shuts off the whole loop. So these loops amplify for a reason. One might be to create fever, as I've already said. The other is childbirth. So we have basically two kinds of loops in homeostasis that you need to be aware of. Negative feedback loops, and I would remember the temperature example, and positive feedback loops. And you want to think of either fever or, for example, childbirth. But all in all, homeostasis is about maintaining that internal balance from everything from our immune system to our digestive system. Any irregularities, and we can get problems. With our immune system, we can get disorders where our immune cells literally attack us. And you might know some of these. Arthritis is an example of that, where your joints get attacked by white blood cells nibbling down your cartilage, right? To other disorders such as immune disorders, the likes of lupus and things like that. These can be, sometimes we can get sick from a lack of a homeostatic balance. Okay, I promise to keep this short and sweet. That's it, folks, and thanks for listening. Ciao.